So the unit 3, CNC programming. So why we need programming is to make the machine understand as per the diagram. It has to perform the operation so that to make the machine understand what it has to do, we have to make the CNC programming. Okay, the motivation and uses. To manufacture complex curved geometries in 2D or 3D was extremely expensive by mechanical means, which usually would require complex jigs to control the cutter motions and machining components with repeatable accuracy. Unmanned machining operations. So advantages of CNC programming is easier to program, easy storage of existing programs, easy to change a program, avoids human errors, safer to operate, complex geometry is produced as cheaply as simple ones, usually generates closer tolerances than manual machines. Okay. Now this diagram shows a conventional milling machine. What you can see here is a vertical milling machine architecture where you can see the head, column, the work table, workpiece, saddle, knee, and base, and of course T-slots. The types of CNC machines based on motion type, you can say point to point or continuous path. Then based on control loops, we can say open loop or closed loop. And based on the power supply, it can be electric or hydraulic or pneumatic. And based on positioning system, it can be incremental or absolute. Now let us see the basic CNC principles. Using a vertical milling machine center as an example, there are typically 3 linear axes of motion. So each is given an alphabetic designation or address. The machine table motion side to side is called the x-axis. The table movement in and out is y-axis, while head movement up and down, the column is the z-axis. Okay. So the basic CNC principles coordinate system you can see. So using the right hand rule, you can see it consists of 3 axes positioned 90 degrees from each other as shown in the figure. And the left side what you see is the absolute coordinate system, and the right one is the incremental coordinate system. Continuing the basic principles, all computer controlled machines are able to accurately and repeatedly control motion in various directions. Each of these directions of motion is called an axis. Depending on the machine type, there are commonly 2 to 5 axes. Additionally, a CNC axis may be either a linear axis in which movement is in a straight line or a rotary axis with motion following a circular path. It can be shown in the figure 6.2 where the coordinate systems used in NC. A is for flat and prismatic work and B for rotational work. On most turning machines, the z-axis is horizontal rather than vertical as we have shown it. If a rotary table is added to the machine table, then the 4th axis is designated as B-axis, and that is shown in the figure. Next. Now how CNC machine works. So it is controlled by G and M codes. These are number values and coordinates. Each number or code is assigned to a particular operation, typed in manually to CAD by machine operators. G and M codes are automatically generated by the computer software. The features of CNC machinery: the tool or material moves. Tools can operate in 1 to 5 axes. Larger machines have a machine control unit. which generally we'll call as MCU, which manages operations. Movement is controlled by motors, or rather than we can call them as actuators, because it actuates certain movement. Feedback is provided by sensors or transducers. Tool magazines are used to change tools automatically. Now, the tools that are used in CNC machining, most tools are made from high speed steel, and that's quite normal. Tungsten carbide or ceramics depends on the workpiece what we use. Tools are designed to direct waste away from the material. In such a way, they are designed. Some tools need coolant, such as oil, to protect the tool and work when they get overheat. Now, tool pass, cutting and plotting motions. Tool pass describes the route the cutting tool takes. Motion can be described as point to point, straight cutting, or contouring. Speeds are the rate at which the tool operates, that is RPM. Feeds are the rate at which the cutting tool and workpiece move in relation to each other. Feeds and speeds are determined by cutting depth, material, and quality of finish that is required or needed. For example, harder materials need slower feed and speed. Roughing cuts remove larger amounts of material than finishing cuts. Rapid traversing allows the tool or workpiece to move rapidly when no machining is taking place. Now, the manual NC programming. As we discussed earlier, the programming can be done either manually or computer itself can generate the program. That is called part program. A computer program to specify which tool should be loaded on the machine spindle, what are the cutting conditions like speed, feed, coolant, on, off, etc. The start point and end point of a motion segment, how to move the tool with respect to the machine. The standard part programming language what we use is RS-274D, Gerber GN code. History of CNC programming. The RS-274D is a word address format. Each line of program is called one block. Now, each block is composed of several instructions to perform or words. You can see in this table sequence and format of words. For example, when I say N3, it is a sequence number. And when it is G2, it is preparatory function. And X plus 1.4, Y plus 1.4, and Z plus 1.4. All these values give the destination coordinates. Like in x-axis, what is the distance, y-axis, what is the distance, and z-axis, what is the distance. And next block, you can see I 1.4, J 1.4, and K 1.4. That are the distances to center of the circle. And next is when I say F3.2, that is a feed rate. Whereas S4, that is a spindle speed. And T4 means the tool, represents tool 1 or 2 or 3 or 4 like. And M2 is other function. One example, let us say here for a manual part programming. Here you can see a triangle shape with a semicircle. So that is the job we need to produce. So here the dimensions are given like 5. Here please note it is given in inches. So in programming we can use either inches or even millimeters. So accordingly we have to write the coding. Now here the tool size, what we choose is 0.25 inch and feed rate is 6 inch per minute and cutting speed is 300 RPM. Tool start position is 2,2. And here you can see last line it is written as programming in inches. So in the motion of tool from P0 to P0, because it has to start from P0 what you can see, the left bottommost corner, you can see P naught, it is 2, 2. So that is the start position. From there, the tool moves to P1, and again it takes upright and go to P2. Then it goes to P3, then makes one radius arc is there. After making that arc, it goes to P4. Then it travels right to reach P5. Then from P5, it returns to P1. So this is a manual part programming example. The set of the programming parameters, as we discussed earlier, it has to reach from P0 to P5. Proceeding from P1, P2, P3, P4, P5 and again P1, P0. So programming in inches, when I say, it has to be given as G70. And for using absolute coordinates, we say G90. And feed in inches per minute. Here you can see that is G94. And spindle speed in RPM, that is given as G97. And spindle clockwise rotation is given as M04. Now the machining conditions we have to set up. So machine that is moving in XY plane, and we use full circle interpolation, and feed rate is there, spindle speed is there, tool number is given, and flood coolant whether it is on or off. So here the condition is coolant is on. Move tool from P0 to P1 in straight line. So as you see in the figure, from P0 to P1 is a straight line. Therefore, we can make a linear interpolation and say in the program N030 G01 and target coordinates is X 3.875 and Y 3.698. So how the interpolation is made is explained in the last two lines. X is equal to 4 minus 0.125, which gives 3.875, and Y is 4 minus 0.125. So in this figure, you can see the cut profile from point 1 to point 2. So in the last slide, you have seen P0 to P1 movement. Now it has to travel from P1 to P2. So again, you can see the target coordinates, linear interpolation are mentioned as N040, G01, X 3.875, Y 9.125. Or it can also be written as simply N040, G01, Y 9.125, because in x-axis there is no change. That's what given here as x coordinate does not change. Therefore, no need to give a separate program for it. Now, in this slide, you can see the cut profile from point 2 to point 3. And here, point 2 to point 3, again, it is a straight line only. Therefore, the linear interpolation is N050, G01, and X 5.634, and Y again 9.125. Now, as it comes from P3, it has to move to P3 to P4. And here you can see how the Y is calculated, 9 plus 0.125 and 6.5 minus X whole square plus 0.125 whole square, which is equal to 1 minus 0.125 whole square. And thus X is equal to 5.634. Next. Now we have to take a cut along circle from P3 to P4. So here all these slides we have seen linear interpolation, which you can understand easily. But now we have to make an arc or a semicircle sort of thing is to cut here. Therefore, here the interpolation what we do is a circular interpolation. And target coordinates again you can see as X 7.366, Y 9.125, and I 6.5, and J 9.0. So I and J represent the coordinates of center of the circle. Now cut from P4 to P5. Again, now the circular path is over. Semicircle we have cut. Now again, it is a straight line motion from P4 to P5. Therefore, the interpolation will be linear here, and you can see the target coordinates as x 9.302, and since y doesn't change, it is not mentioned. Now cut from P5 to P1. So now the tool has to go back from P5 to P1. So and again here it is a linear interpolation, and the target coordinates as seen in step 3, x 3.875, y 3.698. Now point return to home position. Now already the tool moved from P5 to P1. Now it has to go back to home position, that is P1 to P0. So here again it's a straight line, therefore linear interpolation. Target coordinates now you can see x 2.0 and y 2.0, which was in the beginning. And now the program started is to be stopped, therefore it's given as N100 M00 means the program automatically stops. Now the basics of CNC programming. CNC instructions are called part program commands. When running a part program is interpreted one command line at a time until all lines are completed. Commands, which are also referred to as blocks, are made up of words which each begin with a letter, address, and end with a numerical value. Each letter address relates to a specific machine function. G and M letter addresses are two of the most common. A G letter specifies certain machine preparations such as inch or metric modes or absolutes versus incremental modes. A M letter specifies miscellaneous machine functions and work like on-off switches for coolant flow, tool changing, or spindle rotation. Other letter addresses are used to direct a wide variety of other machine commands. Now, the important things to know in the CNC programming are a coordinate system, that is, we say Cartesian coordinates, cylindrical coordinate, or spherical coordinates, where we have x, y, z, and the universe is, or the 360 degree is divided as 0 to 90, 90 to 180, 180 to 270, and 270 to 360. And we should know the units incremental or absolute positioning, and coordinates like x, y, z, then rx, ry, rz. Feed rate and spindle speed are required. The coolant control, on, off, flood or mist. Tool control and tool parameters. Programming consists of a series of instructions in form of letter codes. So the first is preparatory codes, that is G codes. That's the initial machining setup and establishing operating conditions. N codes, the specific program line number to be executed by the MCU, that is machine control unit. Axis codes, X, Y, Z, used to specify motion of the slide along X, Y, Z direction. Feed and speed codes, F and S specify feed and spindle speed. Tool codes, T specify the tool number. Miscellaneous codes, M codes, this is for coolant control and other activities. These are the main programming key letters. See, the first one is O, that is program number, used for the program identification. Because we make many programs, so later on to identify a particular program, we use this O. Therefore, O1, O2 like that. So the first program, say it is drilling operation or whatever it is, we give this program number as O. Now, N is the sequence number used for line identification. G is preparatory function. And X means x-axis designation where it goes. And Y is y-axis designation. Z is z-axis designation. R is radius designation. F is feed rate designation. S is spindle speed designation. H is tool length offset designation. D is tool radius offset designation. T is tool designation. M miscellaneous function. So the commonly used G codes. G00. It is a preparatory code to control final position of the tool and not concerned with the path that is followed in arriving at the final destination. So this 00, it's the final position of the tool and we are not bothered about how it goes. That is not required here. The final destination or the final position is given as G00. And G01 is the tool is required to move in a straight line connecting current position and final position. Probably you would have seen in the previous figures where from P1 to P2 means, so P1 is the current position and P2 is the final position. Used for tool movement without any machining, that is point to point control, linear interpolation takes place. G02 is tool path followed is along an arc specified by I and J and K codes. Here we use circular interpolation. And these are the table of important G codes. G00 is rapid transverse and G01 is linear interpolation. G02 is circular interpolation is CW and G03 is circular interpolation CCW. So CW means clockwise and CCW means counterclockwise or you can say anti-clockwise. So G17 XY plane, G18 XZ plane, G19 is YZ plane. G20 bar G70 used for inch units or G21 and G71 metric units. G40 cutter compensation cancelled. G41 cutter compensation left. G42 is cutter compensation right. And G43 is tool length compensation plus. G43 is tool length compensation plus. G44 is tool length compensation minus. And G49 is tool length compensation cancel. G80 is cancel canned cycles. G81 drilling cycle. G82 counter boring cycle. G83 deep hole drilling cycle. And G90 is absolute positioning. Now here you can see some of the important M codes. M00 means program stop. M01 is optional program stop. M02 is program end. M03 is spindle on clockwise. M04 spindle on counterclockwise. M05 spindle stop. M06 tool change. M08 coolant on. M09 coolant off. M10 is clamps on. M11 clamps off. M30 program stop and reset to start. Now some of the program command parameters. So the optimum machine programming requires consideration of certain machine operating parameters including positioning control, compensations, special machine features. Positioning control is the ability to program tool and machine slide movement simultaneously along two or more axes. Positioning may be for point-to-point movement or for contouring movement along a continuous path. Contouring requires tool movement along multiple axes simultaneously. This movement is referred to as interpolation, which is the process of calculating intermediate values between specific points along a programmed path and outputting those values as a precise motion. Interpolation may be linear, having just a start and end point along a straight line, or circular, which requires an end point, a center, and a direction around the arc. Now, these are the rules for programming. Block format. As we discussed, these codes are given as a blocks. Here you can see such sample block. N135, G01, X 1.0, Y 1.0, Z 0.125 and F5. In the sample block, restrictions on CNC blocks. Each may contain only one tool move. Each may contain any number of non-tool move G codes. Each may contain only one feed rate. Each may contain only one specified tool or spindle speed. The block numbers should be sequential. Both the program start flag and the program number must be independent of all other commands on separate lines. The data within a block should follow the sequence shown in the above sample block. The APT programming example. For example, a cylindrical part is, now here is a diagrammatic manner, it is represented as a raw material which is length is 70 and diameter is 25. Here it may be inches or millimeter or centimeter as per the program. Now the finished part what we are supposed to have is given underneath, where the diameter is reduced to 17.5 and one step is for 20 and next step is for 10. Step turning is to be carried out. Next. Now for this cylindrical part, the APT programming example is given here. So it is started with 0003. So O is the program number, therefore it is 0013 is the number of program. Then N0005 G53, N0010, N0010 T0303. Like this program is written so that what you can see a cylindrical part is step turned as in the figure 2. For all these things we use these codes. Now the program interpretation, as already discussed, this O represents the program identification number, that is 0013. Next. To N0005 G53 is to cancel any previous working 0 point. Suppose already we have set some 0 point, we want to cancel it, means like delete command, it cancels everything. Next. N0010, as we discussed, it is a sequence number, and T stands for always selection of tool, and 303 is the tool number 303. Now when 0005 again, the program number, and G57 is to set the working 0 point as already saved in the previous programs. And as already seen, G00 is for rapid movement. Without cutting it, the tool moves at a faster speed. X26.0 is X location as a diameter 13 from 0. And Z 0.0 is the Z location. S500 is spindle speed is set as 500 RPM. M04 is to rotate the spindle counterclockwise. That can be seen in the below figure. Now here G01, because here it is a linear interpolation because cutting is taking place in the linear direction. And x.20 move only in x direction until you pass the center by 0.1 mm. That is, phasing operation is carried out. And F100, F stands for feed rate, therefore 100 means it is 100 millimeters per minute. With that speed rate, the tool is given. And Z00, so move rapidly away from workpiece without cutting. Z2.0, the movement is 2 mm away from the face. And go to a safe location away from the workpiece, that is x is equal to 50, 25 from 0 and Z is 50 to change the tool, because it has to change the tool to perform the next operation. So safely we move the tool away from the location. And now it is moved to change the tool. Now we have to mention the tool number. So therefore the operation given as T0404, where the tool number is 404. Now this tool is changed. Now without cutting it has to go back. Therefore we give G00, that is a rapid movement. Without any material taking, it goes to the location where it is supposed to take the operation. And now X22.5, that is X location as a diameter, and that is 11.25 from the 0. Z2.0 is a Z location, and spindle speed is set as 500 rpm, that is given as S500. Now linear interpolation, because now the tool has moved to the position, now it has to make the cutting. Therefore G01 is given for linear interpolation. And Z30 move only in Z direction because we make external turning operation. Therefore only in that direction tool has to be moved. And again when the tool is moved, already we have set the speed as 500 rpm. Now feed rate we have to set, that is 100 millimeter per minute, that is given as F100. Now again after making the cut Z00, once the cut is made, now it has to go back. When going back, no need to go with a slower speed because it is not taking any material. Therefore move rapidly away from the workpiece to location X23.0, that is 11.5 from 0, and Z as 2. And now G84, turning cycle for machining the step. So now we have to make the step turning operation, which is given in the figure as red line. So in the red line you can see you have to make that operation, therefore it is called step turning. So X17.5 is the final diameter. Earlier we had one diameter, now the diameter has to be reduced to 17.5 mm. Therefore X is 17.5 is the location. And Z20 is the length of step is 20 mm. So step diameter is 17.5 and length of the step is 20 mm. So that is in Z direction, therefore we give Z as 20. And D0 equal to 200. So finish allowance in X direction, that is 0.2 mm. D2 200 finish allowance in Z direction, again 0.2 mm. D3 is 650, that is we say depth of cut in each pass. For every pass, how much depth of material is taken is given as D3, that is 650, means 0.65 millimeters. Now again after taking the cut it has to go back, therefore no material removing, therefore goes fast, therefore it is given as G00. And Z2.0, the movement is 2 mm away from the face. Now position move to the tool changing location, therefore we give X50 and Z50. And now the program is, after taking the step turn, the program is over. Therefore, we say M30, which means the program is end. Now, next you can see a raw material, which is a block having 70 by 60. Now, for that plate, we have to make the finished part as shown in the right figure. We have to make drill, then all linear interpolation only. And you can see the program as already discussed. Here you can see all N01, 02, 03, all positioning up to 12, and 12 is M02. Okay. Now we go for a tool change in this, where G55, X200, Y80 and all. Since already we have discussed all things, now you can simply go through what is happening. The tool has to make the movement to make the cut, and it has to go back if at all we make a tool change. Otherwise, the same tool will perform the operation. Next. Now setting the datum to the lower left corner of the workpiece, where you can see the circle is done. So that is a point we fix. From that only it will travel. In the Cartesian coordinates we set this, and from that point it has to travel either upward movement or right side movement. In that way we set this. Next. So as usual, the program one means program identification number, then sequence number, tool change, tool number. The start rotating the spindle clockwise with 400 RPM, and go to save position with feed rate 150 mm per minute, and lower the end mill to determine the depth of cut. Move from the lower left corner of the workpiece to the right lower one, cutting with feed 75 mm per minute, that you can see in the figure. Then move from the left corner of the workpiece to the right lower one, cutting with feed. Okay. Now cutting the horizontally up to X30, cutting to X0, Y40. So all these things are given in the figure. So complete the countering means, after completing the country, how the workpiece will be look like is shown in the figure, which can be easily understood. Now repeat 7 times blocks from N003, N009 with incremental offset of Z minus 0.5. So repeatedly we do it. Then finally the spindle is off and the program is end. Okay. Now we have to change the tool. Already the mill tool performed its operation. Now changing the tool. And again setting the datum to the lower left corner of the workpiece. The program identification number is given. Then sequence number, tool change. So now we go for drill with the diameter. Because already in the figure we have seen 2 holes. Therefore, to make that we use a drill bit with the diameter 6 mm and the tool number is T2. Now start rotating the spindle clockwise with 400 RPM. Therefore, that operation is given. Now again after making that, go to save position with feed 150 mm per minute. Stop above the center of the first hole and start drill the first hole. That can be seen in the figure. So first you go and position the drill bit. Then once the drill bit is at the center of the hole, now you can start making the drilling operation. Retract to a position above the hole. After making the hole, it comes back. Then stop above the center of the second hole. It has to go to the second hole for making the drill. Therefore, it moves to the center of the second hole. Now you can see in the figure that second hole is also drilled. Now again it has to go back to the center of the second hole. Then the drill bit has to stop above the center of the third hole. Then you can see the third hole is also drilled. Now again go back to the center position above the third hole. Now only 3 holes we are supposed to drill, therefore that is over. Now the spindle is off. Spindle off. And the program is end, therefore end program.